Hello scholars, welcome back. So today we're still going over fraction by fraction division. And I have stated before a method called the keep change flip method, and I posted a little song that helps to remember the keep change flip method. But today we're going to go over a different method to divide fractions, and we're just going to be dividing across, okay? So in the past I've told you that there are multiple ways to do mathematics, so today we're going to do another method, and you may like it better. So let me know if you do like it better. If you do have any questions, please let me know at the end of the video, but let's get started. So we're going to be on activity 3.3, dividing across. So previously I talked about the keep change flip method where you would change the division sign to multiplication and then we would get the reciprocal of this last fraction. But today we're just going to divide straight across. So as an example, if you look right here, we start off with 7/8 divided by 1/2. Well, we know that 7, look at the numerators, okay? 7 divided by 1 is 7, and 8 divided by 2 is 4. So the fraction form of this would be 7/4. Now let's look at a different method. I'm sorry, not different method, but another example. So we are looking at this example. This is the top of page 221. Let me straighten it out for us. Okay, so Amy and Sandy use different ways to calculate the quotient 3/4 divided by 1/3. So let's look at Amy's way first. So Amy did 3/4 divided by 1/3. Now, she went ahead and found a common denominator. So 3/4 is the same as 9/12. To get this, we would just multiply the denominator by 3 to get to 12, and 3 times 3 to get to 9, because whatever we do to the bottom, we have to do the top. So 3/4 is the same as 9/12. Now let's look at this last fraction. 1/3. We wanted a common denominator. Our common denominator is going to be 12. So 3 times 4 is 12. But whatever we do to the bottom, we have to do the top. So 1 times 4 is 4. So 1/3 is the same as 4/12. Now we have two denominators. We brought both of these fractions down. We have two denominators that are the same. Okay? Now 9 divided by 4, that's what we're going to be doing. The numerator is 9 divided by 4, and then 12 divided by 12, that's the denominators, 12 divided by 12. 9 divided by 4 is 9/4, and we just have 12 divided by 12 is 1, so the answer, the quotient of this whole entire thing is just 9/4, because we did 9 divided by 4, so it's 9/4, and that's all over 1, so that's just going to be the same thing. So the answer is 9/4. Now let's look at Sandy's method. I'm going to move this up. Bring this down a little bit. There we go. Okay. It's kind of blurry. Sorry guys. Alright, so we have 3/4 divided by 1/3. Same fraction that we were doing, same problem that we were doing before with Amy's problem, but this is just a different method. Sandy's doing a different method. So we have 3/4 divided by 1/3. She went across. She did 3 divided by 1 equals 3. And then she put the fraction part right here, okay? Now 4 divided by 3 is the same as 4/3. So right here we have 3 all over 4/3. So 3 all over 4/3. Okay? So then we brought it down, and we're going to go ahead and we're going to put 3 all over 1. So 3, we're taking the numerator of this fraction, this entire fraction, we're taking the numerator, which is 3, and we put a 1 underneath of it. So 3/1 is the same as 3. Then we brought the denominator down, 4/3. We're going to multiply both the numerator and the denominator by the reciprocal of the denominator. So we're just getting the denominator, we're finding the reciprocal, so we have 4/3. The reciprocal of 4/3 is 3/4. So we're going to multiply this by 3/4, and we're going to multiply this by 3/4. Now, when we do this, when we do 3/1 times 3/4, well, 3 times 3 is 9, and 1 times 4 is 4. So 9/4 is going to be in the numerator. Then 3/4 times, 4/3 times 3/4 is just 1. So we have 9/4 all over 1. So the answer is 9/4, just like what Amy said. Now when we look at the back of this page, I'm going to look at the top right here. We are still on 3.3. I know it says 3.4 down here. That's just starting the next section, but we're just looking at the problems back here. So these are the problems that you're going to complete. Now, I just want to emphasize that the questions are asking you about the two methods, Sandy's and Amy's methods, and talking about both of them, how they're similar, how they're different. Now, the complex fraction, it does indicate a complex fraction is a fraction that has a fraction in either the numerator, the denominator, or both. So if you remember, in the examples that were given, we had fractions in the numerator and fractions in the denominator. So that's what they're indicating, complex fraction, okay? Now, I know that this might seem like a lot of steps for one of these methods, but if you look back at this problem, this one was really simple. If we just have 7/8 divided by 1/2, instead of having to do the keep, change, flip method, if we just divided straight across, it would be super, super simple. That would be like easy, simple math we could do in our head. We would just know that, well, 7 divided by 1 is just 7, and 8 divided by 2 is just 4. So we wouldn't really have to use a piece of paper to do this problem in the future. Now, when we talk about the other fractions that we went over today, those you do have to use a pencil and paper. It might be easier for you to do that method instead of the keep, change, flip method, which is great. This is just another way to do these problems. But I do want you to understand both of these Sandy's and Amy's methods, and just let me know what you think. If you have any questions, please let me know. I'm always here to help. Have a great day, guys.